In chapter 5.7, we're going to talk about this man, Carl Friedrich Gauss, the guy to my left with the sweet hat and the mustache. He developed the fundamental theorem of algebra, which seems pretty important if it's the fundamental theorem of algebra, or as he called it, the Fundamentalsatz der Algebra. Fundamentalsatz der Algebra. And what he said was basically, with this theorem, that if a polynomial has a degree of 3, 4, 5, 9, etc., etc., what I mean to say, if it's x cubed, or x to the 4th, or x to the 5th, or x to the 9th, let's say it's x cubed, then it has that many zeros or solutions. So if it's x cubed, it has 3 solutions. If it's x to the 4th, it has 4 solutions, and so on. Now, he did say that some of these solutions might repeat. Let's say you factored out this equation, and you got x minus 3, or x plus 3, x minus 4, and x minus 4. Now there are still 3 answers. The answers are, of course, the zeros are negative 3, 4, and 4. It still has 3 answers. However, one of them repeats. This 4 repeats. It still agrees with the fundamental theorem of algebra because it has 3 answers. Another thing that can happen, let's say you have an x cubed function. Maybe 2 of those zeros are actually imaginary. However, there are always 3. A mixture of real and imaginary answers will always lead up to the amount of answers it should have, the highest exponent in that function, so in that polynomial. So like I said before, in order to do this the real way, like I said in the last video, it would take you forever. When it says find all the zeros of this equation and write the polynomial as a product of linear factors. So it wants you to factor it, and by doing that, find the zeros. However, this would actually take you forever. The first thing you're going to do when you see a problem like this is you're going to look, how many zeros does it have? And you say, well, x to the 4th is the largest term. It should have 4 zeros. Number 1 cannot be the answer because it only has 1, 2, 3 zeros. That's not enough. Number 4 cannot be the answer because it only has 3 zeros as well. So it's either 2, 3, or 5. And let's go ahead and check which one it is. So let's graph that. So x to the 4th plus 6x cubed plus 10x squared plus 6x plus 9. Graph it. Zoom out. And we're going to have something that looks like this. Now, I want to get a better look at that, so let's go ahead and zoom fit, see what we get. Zoom fit's not working for these, so let's zoom back to standard. Let's look at that window. So we really care about, I don't know, from -5 to 0, and then we want to know what's going on up here, so let's open that up a bit up top. So let's go x minimum, -5, x maximum, let's go, okay, 5, y minimum, we don't care about much below that. Let's just put -2. And above it, let's go 20. Let's see what it shows us. Alright, we have a better idea of what's going on. Notice how it doesn't fully cross the x-axis. When this happens and you see like a vertex sitting on the x-axis, what that means is there are 2 zeros at that point because it touches, then touches again as it's moving off. So there are really 2 zeros there. So it still could be either one of these. However, we know the 0 is a -3, so we're going to choose the one that gives us a -3. So x minus 3 equals 0. That's from this one. That means x is 3. That's not correct. And x plus 3 equals 0. X is -3. That is correct. Now, notice there are 2 zeros. So that's 2 of them. Like I said, it writes it twice, squared, because it's a vertex. Notice how there are 2 zeros that are imaginary. You can see them right here where it doesn't come back to the x-axis, what that means is you're going to have two imaginary answers. Now, it's not so clear what those are going to be, but unless you want to do like a page of work, you're going to have to take a guess here and assume that those answers are negative I and plus I. So we're going to get ourselves into a little bit of trouble here. But as long as we can get most of the zeros, we can guess at the imaginary ones. So our answer for this is going to be number 5. Those are all the zeros, the real ones and the imaginary ones. There's one more type of problem we need to look at, and that's something like this, where it says write a polynomial function with zeros, x-intercepts of 4 and 1 plus 5. So if we know the x-intercept is positive 4, then the factored form of that will be x minus 4. Because when you say x minus 4 equals 0, you'll get a function, a factor of 4. Now, when you see 1 plus square root of 5, you know that the factor was actually x minus 1 plus root 5. There's one more problem, though, and that is you can't have one square root without having the negative 1 as well, so you need to remember to write x minus 1 minus square root of 5. There would be another one that's the mirror of this one. However, it always starts with x minus because that's how factors work if you want to get a positive number. So these are your three factors, x minus 4, x minus 1 plus the square root of 5, and x minus 1 minus the square root of 5. Now you should already know if there are 3 zeros that this was an x cubed function. The question doesn't ask that, but I want you to start thinking about that when you're doing these types of problems.